Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 680, valid palindrome 2. So we're told that we're given a string s and we need to return true if s can be a palindrome after deleting at most one character from it. So here's an example. We have ABA and this is just a normal palindrome problem here, and we return true because this is a palindrome and we don't need to actually delete anything to make this string a palindrome, or to detect if it's a palindrome. In the second example, however, this string is not a palindrome, but we can delete the character C. We can delete this character C over here to make it a palindrome. So we'll just end up with A, B, A, because the C, we remove it. And in this example, I'll give it ABC, and this is not a palindrome at all, so we return false. So how would we normally solve this problem? Well, if you've solved a valid palindrome 1, just the valid palindrome, the original valid palindrome question, you know that we can use 2 pointers. We can use a 2-point solution and start from the bottom and start from the start of the string and the end of the string, and compare each character with each other and keep basically keep converging our 2 pointers with each other until they reach the same center point, and then we can return true. Otherwise, we can return false if either of the two characters at any point aren't equal to the same character. So how do we solve valid palindrome 2? Well, the thing we want to do is we want to abstract this valid palindrome function into a separate function, and then when we get to a character which does not match the character on its corresponding other side. So let's say we've got a character on the left side and we've got a character on the right side, and they don't match up with each other. Well, then we can then call our palindrome function again, and then check the palindrome function by either checking the substring where we increment our left pointer, or where we decrement our right pointer, and check if either of those substrings can be a palindrome, and then we can return true. Otherwise, we just return false. So how can we actually get into solving this problem? Well, like I said initially, we want to create our isPalindrome function. We want to abstract away this palindrome checking logic. So let's do that. Let's say isPalindrome, and we already have the string passed in, so we can just have the 2 pointers left and right, and we can say while L is less than R, if string L does not equal to string R, then we can just return false. Otherwise, we want to increment our pointers. So we can say L plus equals 1, R minus equals 1, and then simply return, we can just return true if we don't return false. So that means we've got a palindrome. So that's our isPalindrome function. What we want to do now is actually go through our entire string. So let's get our left pointer and our right pointer. Right pointer is going to be equal to the length of our string minus 1. And we're going to say while left pointer is less than the right pointer. Let's now check again. Let's just copy this logic over here. So the only thing we're going to do here differently is we're going to say if the strings from each character does not match each other, then we're going to check the palindrome if we can find any palindrome by deleting at most one character. So we can say return and then isPalindrome, and we can increment either our left pointer by 1 and keep the right pointer the same, or we can decrement our right pointer by 1 and leave the left pointer the same. And if either of these returns true, then we could find a palindrome. Otherwise, we return false because we have not found a palindrome. And otherwise, we can just do L plus equals 1, R minus equals 1, and then return true again if we don't return false, so that we know that we've found a palindrome now. So let's submit our code and let's check that it works. And we passed all 477 test cases with an optimal solution. So I hope this solution made sense to you. In terms of time complexity, guys, we're looking at an O of n time complexity. And for space complexity, we're looking at an O of 1 space complexity because we're only using a couple of auxiliary variables. So with that being said, I hope you guys enjoyed this video, and I'll catch you in the next one.